Before starting the network analysis, you must know what are the basic elements present in any network. In B3E, you studied that active elements and passive elements. Already we covered this, what are active, what are passive elements. Active elements are those produce electrical energy, passive elements are those absorbs the electrical energy and they produce heat. RLC, resistor, inductor, capacitor are called as passive elements. Passive elements means they won't produce electrical energy or voltage, they absorb. Whereas active elements means battery, generator or crystal, piezoelectric crystal, current sources, voltage sources are active elements. These are the basics. What is a network? Interconnection of various elements is called network. The network elements are further classified into independent voltage source, dependent voltage source, dependent current source, independent current source, like that. These elements again we will see source conversion, how to convert a source, voltage source into current source into voltage source. That will be in network analysis. The basic thing is resistances in series and parallel. Resistances in series and parallel, first we have to know before network analysis. When two resistors or three resistors are connected in series, the total resistance is the sum of all these R1, R2, R3. How you got this? Apply KVL, the total voltage equal to V1 plus V2 plus V3. The incoming voltage equal to total voltage drop. If you send this voltage drop to left hand side, the total voltage becomes 0. By Ohm's law, you can see we can write V as IR. We can write V as IR. From that, I1 R1, I2 R2, I3 R3. But I1, I2, I3 all are in series means it is I. The total resistance RT equal to R1 plus R2 plus R3. This is the basic thing which you studied in B3E, Basic Electrical and Electronics Engineering. The resistances in parallel, when three resistors or two resistors are parallel, the total resistance becomes R1, R2, R3 by the total resistance is R1, R2 by R1 plus R2. That is parallel resistance. How to reduce network reduction techniques? What are the various network reduction techniques available? Those are star delta transformation, source transformation. Star delta transformation we already seen how to convert a star network into delta network, a delta network into star network. Already we made a video, you can see that. Similarly, delta to star connection also we made a video, you can see in the link in description or from the playlist you can see. Now coming to three resistors of 6 ohm connected in star, find the equivalent delta resistance. If three resistors are connected in star, 6 ohm, this is 6 ohm, this is 6 ohm, this is 6 ohm, it is also 6 ohm. Then if you want this RAB, if you want this RAB equal to RA plus RB plus RA RB by opposite resistance RC. All are 6 ohm, 6 plus 6, 12 plus 6 into 6 by 6, 36 by 6, it gives 12 plus 6, 18 ohm. Simply, if all resistors are in star 6 ohm, we have to multiply into 3, 6 into 3. The resistors are in star or 6 ohm, the delta equivalent resistance is 3 into delta R. 3 into star R if you made 18 ohm. When 6 ohms, when 18 ohm is connected in delta, what is the resistance? 6 ohm you will get. What is that indicates? If all are 18 ohm, 18 ohm, 80 ohm in delta, divided by 3 gives 6 ohm. That means delta to star conversion is 18 by 3 or delta resistance by 3. If all resistances are equal, if the delta resistances all are equal, then how to get the star equivalent resistance is by 3. If all star equivalent, if all resistances are star 6 ohm into multiply into 3. This formula we have to remember. Find the total resistance or equivalent effective resistance for the network shown below. Find the total resistance for the network shown below by using network reduction techniques, or if any circuit is given for you in examination, find the total resistance in the sense we have to use star or delta conversion technique. It is a star connection, you can convert into delta. 1 ohm, 5 ohm, 3 are in delta network. 1 ohm, 5 ohm and 3 ohm, this is the delta network. We can convert into star network. After conversion of star network, star means RA if you want, the adjacent arms product divided by sum of all arms. This formula you have to remember. If you want star resistance, the product of adjacent arms divided by the sum of all arms. Similarly, RA, RB we calculated 0.3, 0.5, RC 1.67. After that, this circuit you can redraw. In place of this, you can place a star network. If you redraw the circuit, 0.5 ohm, 1.67, 0.3. Now 10 ohm and 10 ohm are in parallel. These two are in parallel. You can write 5 ohm. 5 ohm, 10 ohm are in series. That is 15 ohm. 5 ohm and 10 ohm are in series. You can write this is a 15 ohm. 3.5 ohm, 1.67 are in series. Finally, you will get total equivalent resistance is 12.61 ohm. The conversion is how to convert star network into delta network. If you know, you can use network reduction techniques. The total chapter we can cover in one video. It is very difficult, but you can see. Obtain the star equivalent resistances for this network. The circuit is like this. You can draw like this also. The circuit. After writing that, if you want RA, the product of adjacent terms by sum of delta terms, you can write RA, RB, RC. You can calculate. RAB is 12 ohm and 13 ohm. 12 ohm and 13 ohm by sum of all resistances. That is conversion. Similarly, you can find RB, RC by using the same formula. Find the current supplied by the battery for the network shown below by using star delta transformation. By using star delta transformation, inside of the circuit, 5 ohm, 5 ohm, 5 ohm are in parallel. 5 ohm, 5 ohm, 5 ohm are in parallel. The equivalent resistance is 0.6. 0.6. R equivalent is 1 by 0.6. That is, what is the when three resistors are in parallel, 1 by R equivalent equal to 1 by 5 by 1 by 5 by 1 by 5, 3 by 5, that is 0.6. We want R equivalent 1 by 0.6, reciprocal of this 1.6. You can redraw the circuit from this. We are writing here 1.6. This one we replaced 1.6 by using network reduction techniques. Now this is in delta, we can convert into star. 1.6, 10 ohm and 15 ohm or delta, we can convert into star. After conversion of the star, you can get this circuit by using star and delta conversion. Therefore, finally the total resistance is 2.81. After conversion of the star, these are in series, these are in series. This series combination, this series combination is parallel with 0.9. 10.6 into 0.9, 10.6 plus 0.9 ohm. Finally, by using two formulas, one is star delta and another one series and resistance, series and parallel resistance formulas, we must know. Similarly, another problem you can see here. Find the equivalent resistance across the terminals A and B. Between these terminals, what is the equivalent resistance? Inside of that, there is a star, there is a delta network. It is also one delta network, one star network. Two delta networks, one star network is there. You can find this RA. First, we drawn 3 ohm, 4 ohm, 5 ohm. 3 ohm, 4 ohm, 5 ohm. This we are converting into star. How we are converting star to delta? You can see. If you know these formulas, you can solve any network. RA is the adjacent arms product divided by sum of delta arms 1 ohm. RA, RB, RC we calculated. We can redraw the circuit. In place of this, we can redraw the circuit a star network 1 ohm, 1.25, 1.6. This we replaced. After that, 1 ohm and 2 ohm are in series connection. 1 ohm and 2 ohm are in series, 1 ohm and 2 ohm are in, these are in series. You can write 3 ohm. Similarly, you can draw the circuit. Finally, you can calculate total resistance. Similarly, another problem, you can solve it. This is the example problem. Take one pen and rough notes. You can solve this. To prepare network analysis, first unit, the network reduction technique is most important. This one you can easily find the current I, this current I in the circuit, also resistance between the terminals A and B. This current I we have to calculate, and also what is the resistance between the terminals A and B. This is the terminal B and terminal A. 100 ohm, 60 ohm, 40 ohm, these are in delta. These are connected as delta. Convert into star by using that. After connection, you can draw the circuit like this. Finally, R is 80 ohm, I equal to V by R. V is given as 160, R is, this is the current ohm. R equal to V by I, 80 ohm. You will get same answer. This is 2 amps. 2 amps is the answer. Find the current supplied by the source. Similarly, another problem you can see. There are so many problems we solve. Those we have to practice. This is also based on star and delta. The entire notes we can download from the link. Now source conversion. The another method to convert to reduce network is source conversion. There are various methods of techniques to network reduction techniques are. Among those, very important is star delta, already over, source conversion technique, source transformation technique. The method of transferring from one source to another source is known as source conversion. Voltage source is converted into current source will be converted into voltage source, is called source conversion. The source conversion includes practical voltage source to current source, practical current source to voltage source. That is, practical voltage source means some voltage, some resistance also there. What is meant by voltage source? You can see voltage source, practical voltage source, always a series resistance, or a series resistance will be there, a voltage source. Voltage source is the active element which has series resistance, whereas current source has parallel resistance. This we have to remember. A voltage source always have series resistance, whereas a practical current source always have parallel resistance. This we have to remember, the current source and voltage source. If you remember this, you can solve easily how to convert voltage source into current source. The source conversion is implemented by using Ohm's law. What is Ohm's law? Define Ohm's law. At temperature remaining constant, when the temperature is maintained constant, the voltage across any element is proportional to current. That is V equal to IR. Voltage source 10 volts and series resistance is 5 ohm. 10 volts and 5 ohm. Convert this into current source. What is I? I equal to V by R from Ohm's law. I equal to 10 by 5, 10 and 5 ohm. 10 by 5, 2 amps. Therefore, current source will be replaced by 2 amps. The arrow mark we can indicate like this. The current source is replaced by, the voltage source is replaced by 2 amps like that. By using Ohm's law, simple method to convert voltage source into current source. V by R gives current. That current we represented here, 2 amps. The parallel resistance, what is the value? The same value will be, we have to place same value here, 5 ohm. That is the source conversion. A current source of 10 amps with internal resistance 5 ohm. Convert into voltage source. Current source is 10, voltage resistance, parallel resistance is 5 ohm. This one. We want voltage source V equal to I into R. 10 into 5. Ohm's law, that is V equal to 50. Series resistance should be 5. From this also you can convert voltage source into current source. 50 by 5 is 10 amps. Current source we have to indicate arrow mark. You don't forget to indicate the current source always downside or upside arrow mark based on current direction given. A voltage source will be V. 50 volts like that. Convert below voltage source into current source. By using Ohm's law, we can convert below voltage source is 20 volts and 4 ohm. 20 by 4 gives 5 amps and parallel resistance is 4 ohm. Now, rules to convert various sources. It is very important. If two or more voltage sources or current sources are there, then when voltage source and current source are connected in series, the voltage source deactivated by short circuit. The voltage source we can deactivate by short circuit. This is the rule to convert various sources because we are using network reduction techniques. The voltage source and current source both are in series. Current always flows in this direction. The voltage source will be deactivated by short circuit. When voltage source and current source are connected in parallel, voltage and current sources both are connected in parallel, the current source will be deactivated. In series, voltage source will be deactivated, in current source will be deactivated in parallel because voltage will be there in parallel, constant voltage. In current will be there in series. In series, current will be there. Therefore, current source only we consider, voltage source will be deactivated. When two sources are in parallel, open circuit, we will open the circuit the current source because voltage will be there. When two voltage sources are connected in series with unequal signs, the voltage is added. You can see the battery. When the battery is like this, plus and minus, two batteries are connected in series, plus and minus with unequal signs, then the voltage will be added. Suppose it is 5 volts, it is 5 volts, 10 volts it will be. If unequal signs only, it will be added. With equal signs means it will be difference will be considered, subtraction will be there. If two voltage sources are connected in series with equal signs, the voltage is reduced, V1 minus V2. If two signs are equal signs, voltage will be reduced. When two batteries are same signs, if it connected equal signs, then voltage will be reduced. You can see here. Suppose two voltage sources 10 volts and 5 volt source are connected in series, then we can add 15 volts because unequal signs here, plus and minus, unequal signs they are connected. If two voltage sources are connected with equal signs, V1 and V2, V1 minus V2, it is a 5 volts, it is a 10 volts. Equal signs minus are connected, it is V1 minus V2 we have to do. That is another. When two current sources are connected in parallel with same direction, the current will be added. These are the rules. You can see the PDF from that, or you can write this. When two current sources are connected in parallel with same direction, the currents will be added. When two current sources are connected in parallel, this is one current source, this is one current source, the current will be added. The resistances will be parallel resistance. What is the formula? R1 R2 by R1 plus R2. These rules are used to convert any network, reduce any network into simple network. Because 10 amps and 5 amps, if it is connected in parallel, we have to add. But resistances also will be added, parallel resistance. Two current sources are connected in parallel with opposite direction, the current will be reduced. Suppose I1 in this direction, I2 in this direction, I1 minus I2 we have to consider. Suppose 10 amps, 5 amps, 5 amps only, but the direction of current will be upward because bigger current is 5 amps. This are we have to remember. Convert the given network into single voltage, single source with a single element. The given network is 5 amps, 2 amps, both are opposite direction, 3 ohm, 4 ohm. Now we can convert into voltage source these two, 2 amps and 4 ohm, by using Ohm's law. 4 into I into R is 8 volts, 15 volts. The sign is different, equal signs are there. When equal signs are there, we have to do difference. The subtraction is a 15 minus 8, 7 volts. After that, I equal to V by R, 1 amp will be. Find the current in 3 ohm resistance for the network shown below by using source transformation technique. By using source transformation technique, how to find the current in 3 ohm resistance? 3 ohm resistor is this one in the circuit. By using source transformation also we can find the 6 volts, 2 ohm, 2 ohm, 6 ohm, 1 ohm is there. Convert 6 ohm 2 ohm resistor into current source. 6 volts 2 ohm resistor, this one we can convert into current source 3 amps, I equal to V by R. By using that 6 by 2, 3 amps, and parallel resistance is 2 ohm. Now 2 ohm and 6 ohm are in parallel, we can convert 1.5. After that 3 amps, 1.5, 2 ohm, like that circuit will convert 3 amps, 1.5 into voltage source. Again this will be converted into voltage source. You can write this voltage source 3 into 1.5, 4.5 volts, 1.5 ohm series resistance. These are in series. Similarly you can convert, you can redraw the circuit by like this. Convert 4.5 volts 3.5 ohm into current source. Again we are converting this into current source. You can draw like this. Now two current sources are in the same direction, we have to add the current. Two currents are added. By current division rule, what is the current flowing through in 3 ohm we can calculate. By using superposition theorem also we use current division rule. I 3 ohm is total current 4.28 into opposite resistance for this 3 ohm is this one, opposite resistance. By using current division rule we can calculate the total current. That current in 3 ohm, the current in 3 ohm is we can calculate by using current division rule. What is current division rule? Total current into opposite branch resistance by opposite branch resistance plus present branch resistance. This is the opposite for this 3 ohm. It is the opposite, it is not, it is in series. That is the current is 2.3. Voltage drop across in 3 ohm, voltage drop also you can calculate. V equal to IR, I into R, the current in 3 ohm into its resistance voltage drop. Voltage drop formula is IR. Voltage drop in DC circuit is IR, whereas in AC circuit the voltage drop is IZ. Power across 3 ohm resistance is P equal to V into I or I square R. If you do power means it is in DC P equal to VI, whereas in AC power is VI into cos phi also will come. Cosine of the angle or power factor will be considered. Similarly another problem you can see, by using source conversion we can find. Now what is ideal voltage source? Define ideal voltage source. 2 marks question will come. Ideal voltage source means a voltage source which produces constant voltage irrespective of the load circuit is known as ideal voltage source. Ideal voltage source means the internal resistance is 0. Ideal. Similarly ideal current source is defined as the current source which produces constant output current. That is ideal voltage source and current source. What is dependent sources? Dependent voltage source, dependent current source are there. Already we seen in previously dependent, the network elements are again classified into voltage sources, current sources, or divided into dependent sources, independent sources. Dependent sources, dependent voltage source, dependent current source. The voltage source which depends on other one, other parameter, other current. It depends on another. Dependent current source means the current in any branch is depends on another dependent current source. The dependent voltage source also classified voltage control voltage source, current control voltage source. These are problems on mesh analysis. It is very important. You will get 10 marks question from this. Determine the voltages V2 in the circuit. V2 we have to calculate for the circuit shown below by using mesh analysis. Mesh analysis in the sense we have to apply KVL. By applying KVL for this loop, for this loop, for this loop, we can calculate what is V2. V2. Now what is super mesh? Define super mesh also one of the. A mesh means loop. A mesh which is not further divided, that is known as super mesh. A super mesh, a loop which cannot be further divided, it is called mesh. What is super mesh? Super mesh occurs when a current source connected between two essential meshes. Between two meshes, if a current source is there, that one is called super mesh. Super node also. Between two nodes, if any voltage source is there, that is called as super node. Between two nodes, it is one node, it is one node. If any voltage source is connected here, between two nodes, if a voltage source is connected here, it is known as super node. These two nodes are called super nodes. Similarly, what is a super mesh? A super mesh occurs when a current source is connected between two essential meshes. Between two meshes. What is mesh? What is loop? A loop which cannot be further divided is called mesh. A loop is a closed path. A closed path of the network is called loop. A loop which cannot be further divided is called mesh. Now similarly apply KVL for this loop, open circuit this one because we have current source. Similarly another one, find Ix and Iy for the network shown below by using mesh analysis. Ix is 1 ohm resistance, Iy is 4 ohm resistance. What is the current? There are two meshes. This is one loop, this is one loop. There are two meshes. Let I1 I2 be the currents in meshes. If voltage source, it is a current dependent voltage source, it is a current dependent voltage source. Two sources are there, two dependent sources, one independent, so two independent sources are there. For this, how to apply KVL by mesh analysis? There are two meshes. First we have to identify meshes. I2 are the two currents. This Ix is the current in this mesh is current Ix is I1 minus I2. This mesh Iy equal to I1 only. This current. Apply KVL for loop 1. If you apply KVL for loop 1, how to apply? The voltage drops will be considered. 5 ohm voltage drop plus 5 volts, all this will be equal to 0. Apply KVL for loop 1, minus to plus. It is minus if you consider, all will be plus in this loop. If the voltage source is negative, all will be considered as plus sign. Minus 5, 5 into I1, this voltage drop, all voltage drops are equal. What is the voltage drop formula? I already told you, I into R. Voltage drop, all voltage drops equal to, all voltages and the voltage drops equal to 0. By using Ohm's law, we are applying Ohm's law for this. 5I1 plus 2Ix plus 4I1. What is the current flowing in 4 ohm? I1. Iy equal to I1. You can write 4I1 plus I1 minus I2. Here what is the current? I1 minus I2 into 1 ohm. We have to write 1 ohm plus 2Iy equal to 0. We have to remember how to apply KVL for this loop. If you consider it is a negative sign, fall in potential. Minus 2 plus means rise in potential. If you consider it is a plus, all should be minus. It equals 0. Or you can consider it is a negative, minus 5, all will be plus. By solving this, you will get one equation, 14I1 minus 3I2 equal to 5. Make it as equation 1. Apply KVL for loop 2. Loop 2 we have to apply. It is 10 volts is there. That minus 10 plus 2Iy. Iy is the current is flowing in this. 2Iy plus I2 minus I1 into 1. I2 minus I1 into 1. The resistance is 1 ohm. I2 minus I1. For this loop, I2 minus I1 we have to consider. I1 minus I2 we have to consider. Solving the two equations, you will get I1, I2. Similar problem, another one. There are two Vx like that. You can see this problem. By using matrix method, Cramer's rule, you can solve this problem. Nodal analysis problem. Nodal analysis means we have to apply KCL. What is meant by node? The junction at two or more elements are connected. That is called node. It is the node for this I1, I2, I3 currents are meeting at this node. A node is a point at which two or more elements are joined together. Remember this, node is a point at which two or more elements are joined together. Node or junction both will be same. The nodal analysis method followed by KCL. Whereas mesh analysis we are applied KVL. KVL for loop 2 or mesh 2. Calculate V0 for the circuit shown below by using nodal analysis. It is also a dependent voltage source and independent voltage source. It is a independent voltage source to V0. V0 is the voltage across 3 ohm. It depends on this voltage. That's why it is called dependent voltage source. Now apply KCL, the sum of incoming currents to outgoing current. Apply KCL at node 1. This is the node 1. Only one node is there. Apply KCL at node 1. I1 is the current, I2 is the leaving, I3 also leaving. I1 equal to I2 plus I3. From that, I1 is the current means V1 minus by 3. What is the I1? I1 is the voltage across this element. I1 is the current flowing in 3 ohm. V1 minus 12 divided by 3. Similarly, V1 minus 0 by 8. Here 0 we have to consider, it is a ground terminal, 0 volts. I equal to V by R, or potential difference. From that we can solve. Next is theorems. These theorems you will get problems or statement. It is very important for 10 marks for network analysis. Thevenins theorem, superposition theorem already we seen in B-triple-E. The same you can prepare. Superposition theorem for AC circuits also you have to prepare. You can see that. Superposition theorem for DC circuits you can see in the link in description. Thevenins theorem. Thevenins theorem states that, what is Thevenins theorem? Any complicated circuit can converted into simple circuit. A voltage, Thevenins voltage in series with Thevenins resistance. It is a complicated circuit. Find the current in RL means that RL will be load resistance will become here. This entire circuit will be converted into one simple equivalent circuit, Thevenins voltage in parallel in series with Thevenins resistance. How to find this one and this one? Thevenins voltage, Thevenins resistance, how to find? That is the theorem. Thevenins theorem states that in any linear bilateral circuit containing several voltage sources and resistances, this entire circuit can be replaced by single voltage source, that is Thevenins voltage source, in series with a single resistor, that is Thevenins theorem. Thevenins theorem provides method of simplifying the circuit into standard equivalent circuit. This theorem can be used to simplify and analyze the complicated circuit. What is the use of Thevenins theorem? To analyze any complicated circuit, we use Thevenins. Thevenins voltage how to find? Thevenins resistance how to find? Thevenins voltage is the open circuit voltage between two output terminals when the load resistor is removed. We have to remove this load resistance to find Thevenins voltage. Thevenins resistance means, what is Thevenins resistance? You have to remember. It is the total resistance appearing between the two terminals A and B, the circuit, when all sources are replaced by internal resistances. Voltage source is replaced by, voltage source will be short circuited and current source will be open circuited. If it is a resistance is internal resistance unte internal resistance place cheyali. అంటే థెవెనిన్స్ వోల్టేజ్ ఫైండ్ అవుట్ చేసి థెవెనిన్స్ రెసిస్టెన్స్ ఫైండ్ అవుట్ చేసేటప్పుడు ఇక్కడ ఏదైనా వోల్టేజ్ సోర్స్ ఉంటే voltage source will be open circuited, current source will be, voltage source will be open circuited and current source will be open circuited and voltage source will be short circuited. That we have to remember. If you do one problem, you can solve this. Thevenins theorem. How to find Thevenins equivalent resistance? You can find the link in description also. Very simply, practically we calculated Thevenins theorem. We find the current through 8 ohm resistance, this resistance, for the circuit shown below by using Thevenins theorem. Very simple method. You can find the link in description how to find Thevenins equivalent resistance, how to find Thevenins voltage. There are two steps we have to follow. Step 1, it is required to find the current in 8 ohm resistance. Involve two steps. Those two steps we have to remember perfectly. To find Thevenins voltage VTH, Thevenins voltage find, if you want, we have to remove this 8 ohm. Because we want to calculate, find the current through 8 ohm, we have to remove this 8 ohm. I am writing here by using sketch. You can find the PDF file in the description. After that you can practice by using pen and paper. Without practice you won't get. To find Thevenins voltage, the voltage which appears across the terminals, first we have to remove this 8 ohm, we have to remove. By seeing these terminals, what is the voltage appear across A and B? That is the voltage across A and B is called Thevenins voltage. V6 ohm, what is the voltage? Voltage across 6 ohm is called Thevenins voltage. The voltage across 6 ohm Thevenins voltage VTH equal to V6 ohm. R equal to total resistance is 9 ohm. If it is a 6 plus 3 in series, this can be neglected because it's a open circuit. I equal to V by R, 4.4 amps. V6 ohm is V equal to IR, 6 into 4.4 amps. 6 ohm into 4.4 amps, you can get 26.4. This is the Thevenins voltage. VTH equal to 26.4. Next, Thevenins resistance we have to find. To find Thevenins resistance, what we have to do? Voltage source will be short circuited. If they given some resistance, that resistance we have to consider. Internal resistance of or source resistance we have to consider. Voltage sources will be short circuited, current sources will be open circuited. That we have to remember. Suppose if any voltage source is there, it will be open circuited. Current source is there, it will be open circuited. In this circuit, we have voltage source, it should be short circuited. because voltage is 0. In short circuit voltage is 0. We are deactivating the voltage source and current source. Deactivate means voltage becomes 0. Current source means if you open, suppose in place of voltage source a current source is there. How to replace the current source? Current I equal to 10 amps, assume that. 10 amps we have to make 0. We have to make open circuit. RTH. But after short circuiting this, these two are in parallel and connected in series to this, that is 7 ohm. This is the simple method to calculate Thevenin's resistance. Step 3, draw the equivalent circuit. What is the equivalent circuit? This we have to remember. VTH, RTH values we calculated 7 ohm and this one 26.4. 26.4. This is 26.4 ohm, 26.4 volts, and 7 ohm is Thevenin's resistance. R is load resistance. What is the value? 8 ohm. 8 ohm we have to represent here. Now we can calculate what is the current in 8 ohm. Current through 8 ohm is VTH by RTH by RL. This formula we have to remember. VTH by RTH plus RL. That is current through 8 ohm is 1.76. Similar manner you can solve this problem. You can see. Another theorem which is very important, find the current through 2 ohm. It is also by using Thevenin's theorem. This solved problems you can find. Norton's theorem. This is another method opposite to Thevenin's theorem. Current source in parallel resistance we have to calculate. Norton's current and RTH. Previously we calculated VTH, RTH. Norton's current and Norton's resistance is Thevenin's resistance. Here common thing is how to find RTH, similarly RN, Norton's resistance also. This value we have to calculate. If you solve one problem, what is Norton's theorem, you can see here. In any linear bilateral net containing a number of voltage source, current source, resistors can be replaced by simple circuit connecting a short circuit current. Short circuit current or Norton's current in parallel with a resistance RTH or RN. This entire circuit can be drawn one equivalent circuit. This circuit we have to remember. How we remember Thevenin's equivalent circuit? Similar manner we have to remember this IN, RN, RTH. RN, RTH both are same. Norton's current means Norton current is short circuiting current. Similar manner, Norton's theorem how to find, you can find the link already. Numerical problems on Norton's theorem by using independent sources, dependent sources. If you have any doubt, comment. And it is about reciprocity theorem. Reciprocity theorem states that, what is reciprocity theorem? The reciprocity theorem states that in any linear bilateral network containing so many elements, so many voltage sources, the voltage current ratio is same. Even the position of the voltage source is interchanged. Suppose 10 volts, 20 amps. If you change that position, this network will not be there. V1 by I1, V2 by I2 should be same. That is reciprocity theorem. Reciprocity theorem applicable when ratio of response excitation is same. You can see Norton's theorem with dependent sources also we solved. Due to time lagging, Norton's theorem first we have to remember. Millman's theorem. Define Millman's theorem. 2 marks question. In any linear bilateral circuit containing more number of voltage sources in series with resistances, we can replace the entire circuit with one Thevenin or Thevenin RL. That what is VM RM we have to find. VM is V1 G1 plus V2 G2 plus V3 G3. We have to remember G1. G1 G2 G3 we have to calculate 1 by R1 plus 1 by R2 plus 1 by R3. That is G2 G1. This formula we have to remember, that is Millman's theorem. The entire circuit can be replaced by VM RM. How to find VM? VM is V1 G1 plus V2 G2 plus V3 G3 by G1 plus G2. G means conductance. It is 1 by R1, 1 by R2, 1 by R3. RM, how to calculate RM? 1 by G1 plus G2 plus G3. The conductance. It is the property of what is meant by G, conductance. It is measured in mho or Siemens. Millman's theorem for AC circuits. If it is AC circuit, voltage angles will be given. You can see that admittance we have to calculate for Millman's theorem. Y1 equal to 1 by Z1, impedance 1 by Z2, 1 by Z3, VM, Zm formulas are these. Similarly, what is meant by resistance? By using Millman's theorem, this type of problems will come for 10 marks. This type of problems will come for 10 marks. Find the current through 9.4 ohm for the network shown below by using Millman's theorem. By using Millman's theorem, how to find V1, V2, V3 are given. R1, R2, R3 are given. These are R1, R2, R3, V1, V2, V3. First we will calculate V1, G1, G2, G3. Formula is, what is G1, G2, G3? Conductance. Formula is 1 by reciprocal of resistance is called conductance. That is reciprocal of resistance 1 by R1, 1 by R2, 1 by R3. G1, G2, G3 we calculated. By using Millman's equivalent circuit, we can find Vm. Vm formula is V1, G1 plus V2, G2 plus V3, G3, whereas G is conductance. So substitute that Vm you will get. Rm is 1 by G1 plus G2 plus G3. This formula already we have to remember. Two formulas we have to remember for Millman's theorem. If you remember this formula, you solve any Millman's problem. Based on Millman's theorem problem, if any problem. Now, we calculated these two values and RL directly we drawn. From that IL we can calculate. Similarly, another problem, V1, V2, V3 are given in polar form, rectangular form. Mostly they will give polar form. Write the rectangular form also. 415 at an angle 0 means rectangular form 415 plus J0, V2, V3. Similarly, Z1, Z2, Z3, first we have to write down. Z1 is R1 only, Z2 is J10, capacitor is there minus J10 we have to consider. Why? Because Z in the third unit you know what is Z equal to R plus JXL minus XC, only capacitor is there minus J10 we have to consider. After that admittance we have to find. Why? Admittance is the reciprocal of impedance, mho unit. Then y, total y we have calculated, total impedance Z equal to 1 by y. V1 y1, V2 y2, V3 y3 we have to calculate. Addition and subtraction rectangular form only. Division and multiplication will be in polar form only, we have to convert. That's why division and multiplication. After that, substituting this in this formula, you will get all this. Similar manner, find the current in 20 ohm resistance for the network shown below by using Millman's theorem. First we have V1, V2, V3. After that Z1, Z2, Z3. After that Y1, Y2, Y3 we have to calculate. By using formula we can find what is current I. First we will find this Vm and Zm. Zm is 1 by Y1 plus Y2 plus Y3. In AC Zm will come, whereas in DC circuit, if it is a DC circuit, only Rm will come. Next is maximum power transfer theorem. This theorem you can understand very easily. The maximum power will be transferred from source to load when load resistance equal to thevenins equivalent resistance. When RL equal to RTH, then maximum power will be delivered. The same thing we explained here. When maximum power will be transferred, Pm equal to Vth square by 4 Rth. How you solve this? You can see the derivation. The maximum power transfer from source to load when load resistance equal to source resistance, or source resistance means Thevenin's equivalent resistance. That is the theorem. By using maximum power transfer theorem, amplifiers, speakers, communication systems, all this will work. What are the applications? 2 marks question. Define maximum power transfer theorem. 2 marks question will come. Determine the value of RL for which maximum power observed RL equal to RTH, then only maximum power will be delivered. First find out RTH for this. RTH if you want to find, voltage source will be short circuit. After that we calculate 2 ohm. Thevenin's theorem. So these are 2 marks questions will come for Thevenin's theorem, compensation theorem, substitution theorem, all this. That's about first unit. Totally we have to remember so many theorems, so many problems we have to solve. If you solve it and practice twice, thrice, then only you will get. Without practicing, watching or seeing, by watching or remembering you can't solve. You have to write the theorems also without seeing the notes. Practice well, you will get success. Thank you.